In this short demonstration, we're going to show how the 9640 can make the process of spectrum analyzer calibration much simpler and faster and less prone to errors, both in terms of measurement error and mistakes made potentially in making the calculations to achieve the results. We're going to look at one of the key tests in a spectrum analyzer calibration, that of scale fidelity testing. A typical spectrum analyzer calibration procedure is very long and time consuming, and the procedure itself often occupies many pages, 600 pages for a family and about 200 pages for a single model. And in this test, the scale fidelity test, we're going to test the linearity of the spectrum analyzer from the top of the screen stepping down in usually 10 dB steps. To perform that calibration, we would traditionally need the use of calibrated step attenuators, and those calibrated step attenuators will be accompanied by a table of calibrated values and uncertainties. We need to take account of the calibrated values when making the measurements and take account of the uncertainties when we compile the uncertainty budget for that calibration. Now, the 9640 is designed specifically for these types of calibration activities, not only in terms of its accuracy and performance, but also in terms of its user interface. It also simplifies the metrology processes by having a single certificate of calibration applicable to the outputs from the leveling head that connect directly to the input of the unit under test. So in this test, we're going to make a measurement at a frequency of 50 megahertz, which is the typical measurement frequency where we have best uncertainty on our calibrated attenuators, at a level of minus 10 dBm and step down by 10 dB steps. So we have the instrumentation set for that test point, and I have placed a cursor on the screen here to enable us to measure the response. So we're going to start at the top of the screen by setting 10 dBs, minus 10 dBm on the 9640, and making a slight adjustment to the level to make that read exactly minus 10 dBm top of the screen on the analyzer. And now I'm going to make use of the 9640 at level step feature by setting a step size of 10 dB. And then I'm going to use the stepping feature to step down in decrements of 10 dB. Here I step down by minus 20 dBs. And we need to determine the error of the spectrum analyzer at this point on the screen. And to do that, I'm going to use the offset feature, turning on the level offset feature, and to use the offset feature as an UUT error. I need to change the units here from percentage to dB. The units of percentage are useful in other applications, but in this case we want to see the units displayed as dB. And now I can adjust here by changing a small change to make the spectrum analyzer read exactly correctly, and now display the error from the correct value directly on the screen. Notice that I do not need to make any further calculations to have that error exactly correct. I can write that down in my calibration results directly, simplifying the process. If I now want to step on further down to the next test point, I can do so quite easily and step on further down the spectrum analyzer display, again relative to the top of the display. So this feature is very simple to use for the scale fidelity test. The specification of the 9640 that is relevant to this test is the linearity accuracy, and under these conditions we achieve 0.02 dBs over this range of attenuation values. For further information on the performance of the 9640A, you can look at the extended specifications document, which is available from the Fluke website at www.flukecal.com.